Hi everyone, today we're going to talk about operations with radicals. Specifically, we're going to look at multiplying, adding, and subtracting radical expressions. When we multiply radicals, we go back to the product rule for radicals and just use it in the opposite direction. So when we have the nth root of a times the nth root of b, we'll be able to put the radicands together to get the nth root of a times b. As always, n will be greater than or equal to 2. We'll start by just taking some radical numbers and simplifying them. As we simplify, we are not going to put these into the calculator. Each time we want to leave the answer in exact form. So exact form means we leave radicals when we can't reduce them any further. Our first one says the square root of 3 times the square root of 21. Using our product rule for radicals, we are going to multiply the 3 times 21. Now we could, of course, multiply 3 and 21 and get a bigger number, which would be 63, but instead I'm going to do this a different way. I'm going to say this is the square root of 3 times 21, I know is 3 times 7. Because what I'm looking for here are pairs of numbers that will come out from under the radical. So now that I've written 21 as 3 times 7, I can see that I have a pair of 3's, which means I get to take that 3 outside and leave the 7 underneath the radical. So our simplified form is 3 square root of 7. Let's use that same concept and try to multiply the square root of 33 times the square root of 22. When we put those together, we have the square root of 33 times 22. I'm going to rewrite that. 33 is 3 times 11. 22 is 2 times 11. And what I see is a pair of 11's. We'll go ahead and bring the 11 outside the radical. And then underneath the radical, I have 3 times 2. So our final answer is 11 square root of 6. We can, of course, add variables to our expression. So here I have the square root of 2x times the square root of 6x. Putting that together, I have the square root of 2x times 6x, which I'm going to write as 2x times 6 is 2 times 3x. So I'm looking for pairs. I have a 2 and a 2, so let's write the 2 outside the radical. I have an x and an x, so the x will also go outside the radical. The only thing inside is the 3, so I have the square root of 3. So final answer, 2x square root of 3. We can expand this to other roots or indexes, so this time I have the cube root of 4 times the cube root of 10. We'll put that together as the cube root of 4 times 10. We know 4 times 10 is 40, but I want to stick with my idea of really factoring these out. So 4 is 2 times 2, 10 is 2 times 5. Now that we have an index of 3, I want sets of 3 so I can bring the numbers outside the radical. So these 3 2's together become a 2. I still have the cube root of 5. Let's make that bigger, bring the variables back in. So I have the cube root of 3x to the 4th y squared times the cube root of 9x squared y. Putting that together, we have the cube root. I have 3x to the 4th y squared. I have 9x squared y. I'm going to factor it out like we've been doing, but I'm going to put the numbers together. So I have this 3 that I'm going to write first, and then the 9, I'm going to write it as 3 times 3. The x, I have to the power 4 and the power 2. Remember when we multiply, we add, so I have x to the 6th, y squared, and y to the 1 gives me y cubed. So I can see that I get to take a 3 out. With the x to the 6th and the y cubed, maybe it's helpful to rewrite that as a rational exponent. That way you can apply the properties of exponents. So we'll have this 3. If I have 6 times a third, that says that's x squared, and then 3 times a third just gives me y to the power 1. We could write that simply as 3x squared y. As we move on to the addition and subtraction rules of radicals, it's important to know that we will be combining like terms. So what does like terms mean? When we get to radicals, it means like terms have the same index and the same radicand. So either they're all square roots, cube roots, whatever they are, they match, and then what's underneath the radical sign also needs to match. So let's look at our first one. I have 4 square root of 5 plus 6 square root of 5. They both have the square root of 5. There's that like part. 4 plus 6 I put together as 10, and then I have the square root of 5. Next I have 8 square root of x minus 3 square root of x. Looking for the matching part. They both are the square root of x, that matches. So I combine the coefficients, 8 minus 3, which is 5, and then I have the square root of x. Sometimes things are not alike when I first look at them, but after we do some simplification, we can make them alike. So let's look at this 7 squared root of 18x plus 3 squared root of 50x. I'm going to say this is 7, and instead of 18, let's write it as 2 times 9x. And then let's do the same thing. Let's look at the 3 squared root of 50x and think that 50 looks like 2 times 25x. This really reveals those hidden square roots of 9 and 25. So the 9 comes out, it becomes a 3. So I have 7 times 3 square root of 2x plus. That 5 comes out, so I have 3 times 5 square root of 2x. 7 times 3 is 21 square root of 2x. Plus 3 times 5 is 15 square root of 2x. So at this point, I can see that we really do have like terms, even though it wasn't obvious when we first looked at it. Now I can add 21 to 15. That gives me 36, and I have the square root of 2x. Distribution kind of puts all of this together. So just like we've done before, if I have a times parentheses b plus c, I want to multiply a times b and a times c and put them together. That could look like the square root of 3 times 5 plus the square root of 15. So I do the square root of 3 times 5 plus I have the square root of 3 times the square root of 15. So my first step was just to distribute the square root of 3 to both terms. We really like to put the 5 in front of the square root of 3. It just looks a little better and we don't get it mixed up and try to put the 5 underneath the radical. But the second one, we can put both of them underneath the radical. So if I look at 3, and then I think about 15 as being 3 times 5, I can see this 3 that gets to come out. So I'm going to have 5 square root of 3, plus the 3 comes out, I have the square root of 5. Now, both of them involve similar numbers, 5 square root of 3, 3 square root of 5, but what's underneath the radical is not the same, so we stop right here. Let's try one more like that. Here I have the square root of 2 times x plus the square root of x. We distribute, so I give the square root of 2 to the x and to the square root of x. So I have square root of 2 times x plus square root of 2 times square root of x. The square root of 2 and x, I can't do anything. I am going to write the x in front and then have the square root of 2. And then the second term, because they're both square roots, I use the product rule for radicals and I put them together as square root of 2x. So just like the last one, I see a lot of similarity in these, but because what's underneath the radical is not the same, I can't put these together and I'm done right here. So for our last problem, I thought we would do an application. An artist is inspired by the inverted pyramid at the Louvre. They want to make a pyramid with a square base that will contain a specific volume. The artist finds the formula S is equal to the square root of 3v over h, which gives us the needed side length S for a pyramid with a volume V and a height h. So what we want to do is find the side length for a pyramid that is 4 foot tall with a volume of 108 cubic feet. Basically, we need to take the information in the problem, plug it into the formula, and solve. So what we're looking for is we're trying to find S, so we'll say S is equal to the square root. 3 is constant, so we don't have to change that. The volume is 108, and then the height was equal to 4. Let's go ahead and put the units in just so we can see what's going to happen as we go through. So you can grab your calculator, do 3 times 108, divide by 4, and it's going to tell you that S is equal to the square root of 81. Feet over feet cubed just reduces to feet squared. So when we take the square root, we're going to get that S is equal to 9 feet. So this says when we construct this pyramid, it'll be 9 feet by 9 feet as the base of the pyramid, which is a square, and then it'll have a height of 4, which will give that overall volume of 108 cubic feet.